extension then? Your student housing extension.
Yeah, I got my extension for another 60 days.
Awesome. And where are you going to go?
I signed a lease at the Covey.
No shit.
Yeah, shit.
That's great. Oh.
Okay. So,
All right. Yeah, whenever you're ready.
now that we're live, we're doing this for security purposes. This is for client Charlie. I name all my clients after letters in the phonetic alphabet.
Okay.
I know it sounds ridiculous, but crazy hackers out there trying to steal ideas. So
yeah. All right.
So, Client Charlie is developing a software geared toward having somebody be able to walk through a blueprint design. Now, there's currently VR software out there that can do these things, but they lack in certain areas and they're not geared toward the specific client. They don't serve a specific opportunity space. They don't provide for the wants of people that are actually. So, from what we talked about yesterday, what do you think is the problem that needs to be solved with our software?
Well, I mean, in a really general way, like VR software can solve problems that exist in the real world before they exist in the real world. The thing I do, and every construction worker does every day, all day, is we will install a whole bunch of stuff, tens of thousands of dollars of equipment, and conduits and wires and ducts, all these, because there wasn't enough pre-thought. And what architects do is they're basically designing a finished product. They want to know, they get where the lights go, and they know what kind of lights are there. But the thing they write on their plan is, determine your own conduit runs, or determine your own ductwork runs, and they'll give you single line riser diagrams, but those riser diagrams or determine your own conduit runs don't actually determine anything in a real space or any kind of real space. So what happens is when we go to install it, we make all these judgment calls, and every judgment call we make has a dollar value associated. Some of these dollar values are small. You screw up somewhere, you have to spend $10 doing it again. You screw up somewhere else, you could spend upwards of $500,000 moving a piece of gear. For example, we're on a project right now where the architect drew a very nice little box and said, put a transformer right here. When you walk into that space in real life, it's perfectly evident there's no possible way you could ever do that. And so here we are stuck with an architect on the phone being like, well, why don't you just put it where the plan says? And an engineer on the other phone being like, what do you mean? Why don't they put it where it says? It's clear that they can't do that. It's impossible. And we deal with these kind of simple problems all the time. But the problem is when we deal with them, like installation is the last step. That's the last thing that happens. So when you're dealing with problems in the last step, we don't deal with one architect, one engineer. We deal with 26 guys on the ground, all getting paid $100 an hour. If we lose an hour, that's, $2,600 an hour we lose instead of one architect and one engineer sitting in a room. One architect, one engineer, and maybe an engineer from a design firm that is not either. See, and the other thing that people kind of fail to understand about the way buildings are built is an architect will put together a big plan. And once they kind of sell this plan to the city, they'll get it signed off by the city, they'll get it signed off by an engineer. They kind of are not responsible for that plan anymore. That kind of becomes all that falls on the head of a bunch of contractors, and especially a bunch of subcontractors, to make their vision a reality, whether that's feasible or not. And there's different amounts the architect is actually involved. But in general, on smaller projects, they basically hand it off and be like, hey, make it like that. Good luck. And so what'll happen is like when they built the airport, right? They built the LAX airport. there was an architect and engineering firm that sent off a pair of plans. These plans went to the major builder, the Clark McCarthy Group. No, wait, whatever, whoever built it. And then they hired Dine Electric and Morrow Meadows and a bunch of electrical contractors. And those guys took these plans and they sent them to their engineers. And it's their engineers' job to kind of hash out all the ugly little details, because their engineers will actually CAD design all the runs that say determine your own runs. They'll actually go in with CAD drawings and determine, you know, the way these 7-inch pipes get through this 10-inch hole, and the way you run, you know, 100,000 amps of bus duct through a building, you know, and under a building and over it. Because however much the engineer is or is not involved, and it varies wildly from project to project. Sometimes you'll get a really involved engineer and a really involved architect that really want to be part of the process. And most of the time on smaller jobs, like parking structures, they don't want anything to do with it. They're like, yeah, I designed the parking structure. Bam, bam, bam. It has 5 levels, it has lights. Go do it, and don't talk to me ever again. And that's what they want. And which is kind of fair, because an architect gets kind of paid one time. They get paid to design a building. Once they're done designing a building, they get paid. They don't want to deal with that building anymore. Especially if it's a building that's not their pride and joy. You know, nobody wants to get known for designing, you know, a warehouse or an airplane hangar or, you know, a parking garage or a Starbucks or, you know, or a little tiny shoe kiosk in the mall. But still, architects are in charge of designing those things. And when they screw up or call out for things that can't physically be done, they don't want to deal with them. They don't want to go back. They've already been paid. So then it falls on the engineers that actually are part of the companies that are supposed to install. So what were we talking about yesterday? Oh, yeah. Who wants this thing? Who wants a product that can figure out these problems? So as it falls out, there's all kinds of people that if they would solve problems before they got to the construction stage could save, you know, potentially multi-millions of dollars every time, depending on the size of the project and how fast the people could utilize this software. Clearly, the people who utilize this software are well-paid individuals. They're making $100 an hour. They're making probably the same as the people who install it. But again, you have 2 people, an architect and engineer, and maybe another engineer, each making $100 an hour. That's $300 an hour. If you can make, but if you could get that $300 an hour to preempt the $2,600 an hour, you would still be making money, you know? So what do you need? This needs to be available to architects, and it needs to be translatable in the same like kind of language that they build blueprints in. And the problem is they still want to use the language they build blueprints in. They want to build basically a finished product. And if you can create a version for them where they can build a finished product and have it look like a finished product in the space, they can get in there and they can walk around, see the lights, see the floor, see the walls, see all the elevation drawings and all the depth and breadth, and zoom out and see plot plans. They would love that, and they would consider their job done. And then if they could then hand that to a more advanced version of the program, where an engineer could go in and be like, okay, now I'd like to peel off walls, and I'd like to peel off, you know, and I'd like to see the columns, and I'd like to see how everything's supported, and I'd like to see what the stress levels are on this particular column. And if I put this piece of gear, let's say you have to put, because this happened to us at City College, this is like some big secret, don't tell anybody. So what happened is when they were designing the retrofit of City College, the engineer decided they were going to put a 500,000-pound air handler on the roof of a building that was built in 1908. And when all the people started building this building, everybody kind of looked at him and said, you're going to collapse the building. It's obvious to us. It was obvious to the steel workers. It was obvious to everyone else. But he just never had the opportunity to like physically look at how big this thing was that he was going to put on the roof of this little building. And if he had ever seen that, it's clear that he would have just designed something else. He would have been like, no, we'll put the air handler on the ground. We'll bury it. We'll figure something else out, you know? But instead of that, what they've had is what amounts to a $500 million stop work on that project. So if you could give a more advanced version to an engineer that would sign off this project. Like, okay, I see this. I can see the air handlers. I can see the ducts. I can see the main electrical feeds. And then he can sign off on the major project. And then if he could hand that off into a more specialized version of the program that's just for AC installers, and it's a less complete version of the program because they don't want to go in and change finishes and see elevations and see all the other things. What they want to do is go in and, you remember like MS Paint? Like when you would go in and you click the little like wand tool and be like, can I draw a tube from here to here? And they could go in and draw all their little tubes from there to there and be like, that's what we're going to do. And if everybody could get together and pass around this little, tube drawing, everybody works in tubes. AC guys are just big tubes. Electricians work in big tubes. Plumbers work in little tubes. Framers work in little steel tubes. Like everybody, if they could all just go in and smash in their little square tubes and see where they would collide. This is where subcontractors would make their money. Because if you could solve subcontracting issues, and almost all money wasted for subcontractors is wasted on where things collide, physically collide. Because the architect will call for, this air handler to feed this space, and also this electrical duct to go through this space. And you physically can't put them in there. And so whoever gets there first, or the air conditioning guys, will run it through that space, and then everybody else has to rearrange their plan. And every time you rearrange, every time you change something in the field, every time you have to write an RFI for something and wait for an architect to get back to you, and wait for an engineer to get back to you, you're running $2,600 an hour wait time. And on really big projects, like if you're building like the downtown high rise, you could be up to $100,000 an hour. And that's stuff that should all be worked out in advance, but a lot of it's just not. But, on really big projects, they do a really good job with these CAD drawings. Sure it is, but not every time. And especially because these CAD drawings aren't accurate representations of real space. You can't go into a CAD drawing and be like, I see that this is not going to work. And you especially can't pass a CAD drawing from one trade to another and be like, can you add to this CAD drawing? Everyone makes their own. They get there and everybody's like, oh, this is fucked up. The way they used to do it back in the day is they would actually create, you would print your blueprints and you would draw where you wanted all your stuff to go. And then you would print it on like rice paper. And you would stand around a big light table and you would lay it down on top of each other. And everywhere that, you crossed each other, that's where you're going to have a problem. And they do that same thing with CAD now. But clearly, two-dimensional prints solve one set of problems. Three-dimensional prints to CAD drawings solve another set of problems. And then a virtual reality world would solve a whole different set of problems. Every time you can see more completely the problems that are ahead of you, you can solve more in advance. More problems solved in advance mean more money made by the contractor. And especially because if you can, there's this other thing that contractors do, and especially subcontractors do. It's that they preemptively find problems that are going to come up and create change orders for them. So, for example, we were handed a set of prints to an auditorium. And right away, my boss said, this job is bid at $500,000, but we're going to make $1 million on it. And I'm like, why? He's like, because they didn't include any fire alarm or data in these prints, and they want it in there. And unless they hired somebody completely else to do it, they just forgot. And if you just forgot but still want it, that means you're going to pay a mint to have the people who are already out there do it. And so these clear oversights are way subcontractors make a lot of their money. A lot of subcontractors will take a job for zero profit, knowing that there were these massive oversights built into these jobs from the architect. And that's a problem for architects first. They should be paying attention. It's a problem for general contractors second, because if they don't catch these, then they're going to end up paying their subcontractors who are making a lot of money on these change orders.
You dared me to do this,
And
so I have to look like you.
so both of those people want this program. The general contractors want it to stop that kind of oversight. And the subcontractors want it to catch that kind of oversight enough to make a lot of money on it. And why is And in a real utilitarian way, if you could go in there and basically, as a tradesman, go into a space and virtually build everything you are going to build. Like, it takes me hours and hours to run 100 feet of pipe, but if I can magically wand myself 100 feet of pipe in 3 minutes, or magically wand myself 10,000 feet of pipe in a day, I could physically work out everything that was going to be in this space and then go into that space, give everyone I worked with access to this virtual reality world and be like, if you're ever confused on what to do, put these glasses on and do exactly that. The other thing that could be amazingly beneficial is if it was linked directly to, and I said it should interface directly with current cost calculating tools. Because clearly, if I was going to go in there and run this 100 feet of magic wand pipe somehow, it could easily calculate how much that thing cost me. I could tell it how much it cost me to run 100 feet of pipe. I tell you it takes 4 hours for me to do it, and I tell you it costs $65 to buy the pipe and $85 to buy the fittings. And it could cost calculate that. That's just math. It's no problem for the computer. Labor plus materials equals cost. So, and if it could interface with current cost calculating software, or even better, if it had cost calculating software that was proprietary that worked with it, you could have, because right now we have our cost calculating software is accurate like plus or minus 20%. Like, it's like grossly inaccurate. And the more you can narrow that down to a real deal number, the closer you're going to be able to bid jobs and still make money. Or if you can go into a space and realize that the problems you're going to have will allow you not to make any money on the job, you could just drop it. Can you imagine if contractors could not take jobs they could not make money on? Contractors are in the business of losing money on a third of their jobs. It's a fact. Better contractors lose money on less. Worse contractors lose money on like half of them. But, I work for a pretty good contractor. We still lose money on about a third of our jobs because there's not good enough ways to predetermine whether the job is doable and can make money on it. And that's what everybody wants to know. They want to know if they can do it and if they can make money doing it. And those are the things the program should solve. It should allow the architect to pass to the engineer to pass to the tradesperson, and each and every one of those people to do the two things they really want to do. They want to get done, and they want to get done fast. It needs to save time in installation for me. And they want to make money. I like making money. I mean, it doesn't matter to me because I just install. I make money one way or the other. But it sure is nicer to work on jobs that make money because everybody's happier. And if you could go into here's the other thing it really needs. It needs to have a way to walk into a space some virtual reality spaces, you're creating the whole thing. You walk into a dirt lot, you create everything from ground up. But in more than half of construction, what you're actually walking into is a space that's predetermined. You're walking into a mall that has this space that you're going to turn into a 99-cent store, or you're walking into you're walking into a high rise and it's this floor and it has predetermined things that are already in there. It already has elevators. It already has ceiling joists. It already has, columns in certain places. And so if you could basically 3D scan the entire thing and start from that point, it's well and good to go take a picture and measure where all the column lines are, but you don't get there's little details, like how the columns actually connect to the grid in the ceiling. What kind of ceiling is it? Because if it's a different kind of ceiling, it makes a difference. It can cost plus or minus $10,000 to install something on that ceiling. Robinson decking, you can just drill into it. Well, let's say it's a plaster ceiling from 1901. It'll look different. All you'd have to do is look at the picture to see that it was different. But they don't 100% of the time check that out when they're sending prints out, and the bidders don't go look at the space. The guys who do the bidding, the guys who do the engineering, they whatever. It's a ceiling, it's the same as a ceiling.
So now that you said that, you were thinking of the idea of being able to pull plans from the city. The problem with the plaster walls and whatnot is I wouldn't be able to get stuff like that data from the city. So do you think that would be cost effective?
I mean, you would have to actually physically go to the space and scan the space. You could never create any kind of model from plans that the city has. First of all, the city has outdated plans. You need to be able to go there and take a 3D picture of the space and send it to the end. And if you could send it to the architect would know way more than they thought. Like, they would have details they didn't know existed. And they could actually go into that space and measure things like how far apart really are the ceiling joists? You know, because a 3D picture, you know, and the engineer would know what kind of ceiling joists were in there. They'd be like, oh, this is an I-beam ceiling. You can't be hanging, you know, or whatever. But there's like little details that we see when we're there that they never see because they never have to go. Or they've maybe been there one time and they just forgot. And they're like, yeah, I took some pictures and I don't, but if they could step into a space, they could be like, oh, I'm going to measure it. I'll know exactly what it is. It's perfect, you know. We've gone on there and gotten plans from architects where the door to the elevator voice faces the wrong way. And you're like, you can't change that. But if they could just snap into their virtual space, they could be like, oh, there it is. Screwed it up. You know? And that costs $10,000. You know, that little mistake. So, because you got to send it back to the engineer, and the engineer has to send it back to the architect. The engineer has to send it back to the city. The city sends it back to us. And meanwhile, we were all just sitting around. You know, you can't get that kind of stuff done in a day, even though it's a simple problem. He just moved the door from here to there. But that kind of simple problem becomes so expensive. And and also the other thing that is crazy and happens all the time is that they really like, especially higher end stuff, they really like cabinet work and like fixtures, and like in retail stores there's all these little islands and booths and wall hangings and stuff. They really like those to be made in Europe and shipped over because they're classier, or made in China or Hong Kong or somewhere crazy. You know, there's 11 million people in my city. I guarantee one of them could build those, but that's not the way they roll. They have them shipped out, and every time they're shipped back, they're screwed up. I've never seen it once happen where they ship them off to France to be built, and they ship them back here, and they're perfect. It's never happened. I just did a bathroom, and they spent $40,000 on, you know, those little partitions between the toilets. Spent $40,000 on these really nice hardwood partitions. He ended up throwing them all away because they were so screwed up. You know, but again, if they could have, with the set of plans, like, hey, we want partitions. This is how it looks. Sent that digital file off with the measurements, and you probably wouldn't even have to send measurements. They could go into that space and measure them, and then you would see simple problems in that same bathroom. The partitions went all the way to the ceiling, but they only put in 3 lights. So 2 toilets, when you sat down on the toilets, completely pitch black. No light in there at all. And it was a joke. Like, when we put them in, as soon as those partitions went in, we're like, are you kidding me? There's no light in the bathroom. You're going to shit in the dark. That's classy. Nobody wants to see anyway. And it was such an embarrassing thing for the architect. We called the architect up and we're like, you didn't want people to see what they were taking done? That's cool, but they got to find the toilet paper and stuff. And, you know, they were embarrassed, but they're like, oh, this isn't our fault, blah, blah, blah. They made them in Britain. They didn't know what they were doing. Like, calm down. But if this is the kind of problem, the kind of multi-$1,000 problem, that if you had a virtual space, you would never have it. He would see it in the virtual space. He'd be like, oh, there's no light there. And then he would put a light there in whatever program and whatever aptitude, way, shape, interface it had. He would have just popped them in. And his seeing that in a real deal way would have saved us $10,000. You know, every time something gets screwed up in the field, it costs a lot. And every time something gets screwed up on a piece of paper, on a drawing, in a program, it's really cheap. You know, so no matter how expensive the program is, or the variations of the program are, it's still cheaper than sending 10 guys to sit and do nothing because they don't know exactly how to proceed. I don't know. Is that enough?
That that was definitely more than enough. When we were talking with Nico yesterday, you know, he had a whole bunch of inputs and he was nodding his head the entire time. So everything is basically very accurate in the situation.
Yeah.
It's very in depth. The information that you gave us basically gives us a competitive advantage in design against people who are working on this style of software and just not following through with it. So
Yeah, no, it's the thing is, whoever makes this, whoever can do it, you know, if it's as good as the Adobe Suite is, it'll become industry standard instantly. They'll be like, oh, this is what we use now. It's like when you write scripts, you use a certain program, and that's the only thing anybody uses. And when you make movies, you know, you use one of two programs when you edit movies. Like, if it's good enough, it'll be indispensable. Everyone will use it. And with the new, like, physical, what do you call it? The hardware that's coming out, the new glasses, they're hooked to the phone. I've never seen anything like that. It was brilliant.
well, the current hardware that we're using is the Gear VR, and of course the big one that's coming out hasn't come out publicly yet, the Project Tango device.
Mocha Frappuccino.
We have several of those, and what the Project Tango is very good at is it's a tablet you can walk into a room and map the entire room.
Yeah.
So,
So with this kind of like, and they're cheap comparatively, you know, these glasses, these 3D glasses cost as much as like a tablet. You're not breaking the bank on these bad boys anymore. Whereas like 10 years ago, you want to buy a VR setup that did all like nothing. It was like $100,000. So somebody's going to invent this, and whoever invents it is going to is either going to sell their shit off to Google right away for a couple $1 million, or they're going to make multiple $1 million each and every month. But it's whoever gets there first, you know. But it'll become indispensable. It's the way everything is going to be done. There's no way to not do it this way. I don't even think I want to do it this way because I don't think I want my boss knowing what I see all the time. But the fact is, like, there's like two facts in construction that we deal with all the time. One, in 5 years, you're going to have to speak Spanish or not do construction anymore. And two, computers are going to replace people in labor. You have to do that. You have to do technology, or else you're going to get demoted. And every person who learns how to do it gets promoted, and every person who doesn't learn to do it gets demoted. And the faster you can push technology along, the more money you're going to save on for these big projects, for these big guys. And, you know, and that's the thing is, as soon as it gets good enough, one of these big guys, a Halliburton, a Dynacore, you know, one of these guys is going to latch onto this and be like, yeah, you're going to develop a special set for us. You're going to develop a special set of plugins just for doing power plants. You're going to develop a special set of plugins that just does long distance cable runs. A special set that just does air handlers. You're going to develop these huge like plugin markets. You know, oh yeah, you bought the program, it cost you $15,000, but now you need the $5,000, you know, long distance cable run package, and that goes along with it. You know, and every specialized construction thing, you know, oh, we need a specialized plugin to do harbors and docks, specialized plugin to do, you know, offshore drilling rigs. You know, these things are all going to have to exist, and they're all going to exist very soon. And if you make them exist, you will be the beneficiary of your efforts.
Tall half calf latte.
well, you know, everybody who talked to you in the last couple of weeks, you know, says, you know, we have to have Peter around to do stuff because, you know, he's very insightful to how the software is going to develop. So, Nico and Will were very happy to meet. Yeah, this is priceless.
I do got to get back to the boat, though.
Absolutely. So I'll
All right.
let you get on with the rest of your day.
All right.
You for your time.
God, you are welcome, man. I'll talk to you soon. I'll hit you up later.
Okay. Thanks, Peter.
Pass it around. Don't show it to the architect. I think I talked shit on those guys too much.
Well, I won't. It's for
Okay.
one science reason.